For today's meeting, we are going to discuss some ions arranged accordingly into the periodic table. So we have to discuss first the ions or the elements found in group 1, period 2 of the periodic table. So this is where the group 1 is, and in the orange mark, you can see here the different elements that could be found in group 1. So it is found in the borderline of the periodic table in its left side. So if you are holding a periodic table, you will come to discover or know or realize that the elements involved here, you have here hydrogen, but that we are not going to include here because we have discussed already the hydrogen and its role in analytical chemistry. Uh, for this session, we have to discuss the lithium, sodium, potassium, rubidium, cesium, and francium. All of them belongs to group 1, and they are also called as the alkali metals. Okay, group 1 and 2 are always found in nature combined with other elements. They are called active metals because they readily uh, form new substances or react with other elements. And they are all metals except what I have told you, the case of hydrogen, and that we have discussed already. Although hydrogen is placed in group 1, it shares property with the elements in group 1 and group 17. The group 1 elements have a specific family name, that is the alkali metal. All the alkali metals are silvery solids with low density and low melting point. These elements increase their reactivity or tendency to combine with other substances as you move from top to bottom. So in this case, the most reactive is actually from lithium going down to francium. Here are some facts about alkali metals. They are related to words like down the hydrogen. The valence is 1. They have only one shell. They have hydrogen with them. And of course, they have the nucleus that are the same. Okay, let us try to make some games. Please fill in the blanks. These metals or the alkali metals all have blank electron in the outer shell. So you could choose from here. So what do you think is your answer? And another fact that you should not forget related to the words mentioned is that reactivity increases as you go blank, the group. This is because the electrons are further away from the blank every time a blank is added, so they are given up more easily. And another fact is they all react with water to form an alkali, hence the name and alkali metals. So were you able to have the answer? Now let us try to look into the family portrait. First you have here the alkali metals. In the first row, you have here the symbols, of course, followed by the atomic mass, and also likewise common oxidation state. So as we have made mention, we are not going to start with hydrogen, but rather with lithium. So this is their physical appearances or how they are found in nature. So they are silvery, they are metallic, white, silvery in color. So this is a glass of lithium, and then you have here a sheet of sodium, and then you have here a bottle of potassium, also likewise with rubidium and cesium. We do not have an available sample for potassium. And now in terms of radius, if you notice, it is arranged smallest from the lithium or from the top, but it goes bigger in terms of radius, both atomic and ionic. So as you go down, the size also increases. Now let us try to look into another physical properties, like for example electronegativity. Lithium has the highest electronegativity, and as you go down to sodium, potassium, rubidium, cesium, and francium, electronegativity decreases. And then in terms of density, okay, you have there the density colored brown. The density of lithium is lower as compared with sodium, and as you go down to potassium, rubidium, cesium, the density increases. Okay. Now in terms of boiling point, the highest boiling point goes to lithium, and as you go down the periodic table, the boiling point also decreases. And in terms of melting point, it has similar trend with that of boiling point, that lithium has the highest melting point as compared with francium. Okay, here are some chemical properties or other characteristics of group 1A in terms of reaction. Okay, alkali metals are powerful reducing agent. They are usually used as an example in explaining reduction oxidation. So they're they're easy to balance because they only contain the plus one cation. So it is easier to play as compared with plus two or plus three. Alkali metals reduce halogens to form ionic solid as a plus one element. Alkali metals react vigorously with water, and then they also reduce hydrogen to form ionic hydrides, and most importantly, alkali metals reduce oxygen in air and tarnish rapidly. So these are usually stored in tight container. Although most of the container are also transparent, no? So these are the common chemical property in terms of reaction to the environment. Okay, what are the other properties of alkali metals? Alkali metals are the largest elements in the respective period, from top to from left to right, from top to bottom. Their size also differs. So alkali metals have their balanced electron configuration of S1. So 1s1, 2s1, 1s1 of course for hydrogen, and then 2s1 for the next, the lithium. The valence electron is relatively far from the nucleus, resulting weak metallic bonding. And hence, the alkali metals are unusually soft for metals. They can be cut easily with a knife. That's why most metals in or most alkali metals are used in electroplating because they could easily be deformed in order to meet the shape that blacksmith or metal workers are working for. Alkali metals have lower melting point and boiling points than any other metals, and alkali metals have lower densities than most metals. So you could just simply have a trend that from left to right, the melting point and boiling point is arranged from low to high, going to right, no? And from left to right, the densities are arranged also increasingly. Okay, this is a lithium. This is a metal, but lithium floating in oil. So this is the water, this is the oil. And even though this is oil, the lithium still floats. That's how light is lithium. And then we have also here potassium. Potassium reacts heavily with water. As we have made mention, alkali metals are very reactive, especially with water. Now let's go to group 2, or the alkali earth metals. The first one is alkali, and the second one is alkaline earth metals. It is composed of beryllium, magnesium, strontium, radium, and barium. What are the trends that we could observe from the elements found in period 2? The atomic size generally decreases across the period. Same trend as that of group 1 or period 1, sorry. And then you have ionization energy and electronegativity decrease across the period. And then metallic character decrease across the period. So in terms of atomic size, ionization energy and electronegativity, metallic character, it decreases across the period. But for the case of oxides of the elements, they become more acidic across the period. Hence, reducing strength decreases through the metals and oxidizing strength increases through the non-metals. Okay, let's try to know them by element. Okay, this is how a lithium looks like. This is how a beryllium looks like. And this is how boron also looks like. And of course, you are familiar with this, the carbon, no? And the diamond. Okay, let's go to the first line. All of all of them belongs to the A group. So lithium belongs to the group 1, and underneath 2A is beryllium. Next to 2A is 3A, the boron, and then the carbon for A. Okay, so they are arranged in the periodic table also based on atomic number, starting with lithium with number 3 atomic number, and then 4 for beryllium, 5 for boron, and 6 for carbon. Hence, if we're going to spread their electron configuration, this is how the helium looks like. And then we have here beryllium, and then for boron, 3. So that is 1A, the group. Have only one uh, orbital. And then you have 2A, you have the 1, 2. And then for boron, you have 1 complete first the per cell, 2, and then 3. There is also another way of doing this. You start all with the up, 1, 2, and then you go back here to fill up where you last attended to. So you have here 1, 2, 3, 4. Okay. And then of course, lithium and beryllium are well-known metals, although lithium is more so as compared with the hard beryllium. And then you have boron. Boron is a metalloid, it is very hard. And then of course, carbon. Carbon is non-metal, no? And you will meet carbon for the whole semester, this semester in your subject. Or you have met already, no? You are done with your organic chem. So you have learned that carbon is a non-metal and it becomes crystal at extreme extreme hardness. Okay, lithium has low melting point, beryllium has high melting point, and then boron has extremely high melting point, whereas for carbon, extremely high melting point. So generally the melting point is very high. Okay. There are some literatures that also supply the figure or the number for the temperature for each of these elements if you are interested. Okay, let us try to look into their periodic character in terms of atomic, physical, and chemical properties. Okay, again, the elements are arranged from 1A or group 1 to group 4. Following also the atomic number from 3 to 6. Now, general reactivity or how they react into chemical reaction. Lithium is not very. Lithium is reactive. Beryllium has a low reactivity at room temperature. The same true with boron and carbon. However, for the case of carbon, its graphite form are more reactive. And then how about bonding among atoms of elements? Okay. For lithium and beryllium, they are metallic. So they bond themselves as sorry, metals. And then for the case of boron and carbon, they bond covalently. So in terms of bonding with non-metals, lithium bond is ionic, and then polar covalent bond for beryllium, the same true with boron. However, in the case of carbon, as you have learned in organic chem, it is covalent because of the pp bonds or the pi bonds. And then how about bonding with metals? In terms of group 1A and 2A, they are metallic. They are also polar covalent for the case of boron and carbon. Okay, in terms of acidity, lithium is strongly basic, beryllium is amphoteric, boron and carbon are very weakly acidic. Redox behavior. In terms of lithium, holding the +1 oxidation state or oxidation number has a strong reducing agent. And then for beryllium, holding the +2 oxidizing number, they are moderately strong reducing agent. So beryllium is weaker in terms of redox behavior. And then we have sorry, complex hydrides and good reducing agent for the case of boron. In terms of carbon, of course, every oxidation state from 4 to -4. Okay, these are practical notes as to how you could meet the different elements found in period 2. Okay, lithium uh, are usually used as soap in order to remove grease in uh, automotive shops. They are also used in thermonuclear bombs, in cleaning, and then high voltage also, or those highly sensitive in terms of electricity and pressure. They are also low weight batteries, and then they are used in the treatment of bipolar disorder. This is a medical function. Okay, generally all of the elements they are involved in the production of uh, rocket nose. So they are essential parts of sensitive metals, both in hospital and nuclear reactors, or even in the making of sensitive arms, especially in the production of its casing. And then all of them are also involved as a cleaning agent. Not only lithium, but lithium is uh, very good in auto grease. So they are all borax is a cleaning agent. If you have heard of boric acid, um, the boric there is derived from the element boron, or it implies the presence of boron. And then the glass sensitive, that is not sensitive to heat, the borosilicate glass are also made up of boron. The Pyrex glass, or those things that we use in baking, we use in cooking, or those glasses that do not break at high temperature are usually made up of borosilicate. So the ones that we are using for making baked macaroni uses a glass tray are usually made up of borosilicate. Also likewise in the coffee maker, the glass dispenser there is also made up of silicate. Most of your apparatus, the one at my back, are made up of borosilicate regardless of their brand. So the Pyrex, the Climax, these are made up of borosilicate. And then as graphite, they are used as lubricant and of course as a structural fiber. And then carbon at crystal state is a very expensive crystal. It is called the diamond. And then of course you have the limestone. Uh, Limestone used to be the material in the production of the blackbird chalk. And then, of course, as carbon, they are they are actually made to prepare the different organic compounds used in the medical world, especially now. The expensive fuels, our basic clothing are also under the period 2 because of the element carbon. Okay, we have also another group of elements in still in period 2. We have the nitrogen, oxygen, fluorine, and neon. So nitrogen has an atomic number of 15, oxygen has 16, fluorine has 17, and neon has 18. In terms of oxidation number, you have nitrogen for 7, oxygen for 8, fluorine 9, and neon as 10. So they are all gases. The fluorines plus here in the picture contains nitrogen, in this case oxygen, no sample for fluorine, and then you have here neon. So highly implied, they are all gases. So they, as a gas, they have very low melting point and boiling point. Now let's try to look into the other properties. These gases are arranged from being inactive to very reactive, extremely reactive, but the neon that is chemically inert. From nitrogen to oxygen to fluorine, they work with covalent by elements. So you have N2 for nitrogen gas, O2 for oxygen gas, F2 for fluorine gas, but not for neon. And then they are all ionic except again for neon. They are acidic but not totally proven for the case of oxygen. And then every oxidation state for nitrogen is from +5 to -3. For oxygen, as a strong oxidation state, it carries the -2. And then for fluorine, the -1, being a halogen or part of the halogen family. Okay, these are the practical functions or importance of the elements. So they are seen from soil development and also likewise to the air. In terms of trends in the periodic table, you can see here the lithium to neon decreasing in terms of atomic radius. But in the case of electronegativity, it is actually increasing from lithium going higher towards fluorine. We know very much that the halides or halogen has high electronegativity. And then in terms of first ionization energy, I would like you to look into your periodic table to see the trend because this is neither increasing or decreasing, but rather it follows the zigzag. So lithium, where can you see lithium? And then beryllium. And then it goes down when it reaches the boron. And then up again for carbon and then nitrogen. And then down again in oxygen, fluorine going up, and neon going up. I would like you to see in your periodic table the location of beryllium, nitrogen, and neon. Do they have a similarity? Also likewise where lithium is, boron, and oxygen. However, there are some anomalous behavior as to how they are arranged in the periodic table. Lithium is the only element in period 2 that forms a simple oxide and nitride. All beryllium compounds except covalent bonding. So if beryllium is acting with another element and also another element forming different compounds, all of those were attained through covalent bonding. And then the borons work with hydrogen in order to form bonds. And here are the electron distribution of beryllium, the electron cloud formula. So you have here beryllium acting with chlorine. And you have here beryllium that could also still work with other more chlorine. Okay. Okay, what are the reasons why period 2 exhibit anomalous behavior? Because small size of these atoms, they have high electronegativity, and also likewise uh, their radius or their size in radius is uh, high as compared with their charts. This element has only 4 valence electrons available as compared to 9. No? This is already referring to the anomalous behavior in period 2 exhibited by the gases, including the carbon. And then we have the lattice energies for group 1A and 2A. So they are also arranged from lithium or from highest going down to the lowest. So this is their chlorine lattice energies. And then for the group 2, their chlorine uh, lattice also uh, arranged from beryllium or from highest going down to the bottom of radium. Okay, this is where they are as found in the periodic table. So this is your lithium group, this is your beryllium group. So the arrangement here from here actually leads to the anomalous periodic properties of second period of elements. But generally, they are still all the same. Okay, this is the diagonal arrangement in terms of relationship and periodic table. So, the nearest element in which lithium is similar with is not beryllium, but rather magnesium, no? Just as the same with boron and silicon. Common properties to all, of course, they are all found in the second row. They do not occur as free elements, but the gases even occur as a binary compound. They are usually found as carbonates, silicates, and sulfates. And usually, since they are in group 2, they can lose 2 electrons or share electrons. Most are insoluble and slightly soluble, but even then they are very reactive. So this is all for our discussion for period 2 and 3, period 1 rather. So read again when the next lecture will be assigned in your Google Classroom.